Hi everyone, welcome to today's lesson on naming and formulas. In this lesson, we are going to review the rules for naming and writing formulas of ionic and covalent compounds. Then we will learn how to name acids and hydrates. So we're first going to talk about writing formulas for ionic compounds. And so just to recap, ionic compounds, they are a type of compounds that are formed by the electrostatic attraction between cations and anions. And so if you remember, cations are positive ions while anions are negative ions. So here's an example. Write sodium sulfide as its chemical formula. So the first thing we're going to do is we're going to determine the symbol of the first element. So the first element here, sodium, if you look on the periodic table, the symbol for that is Na. Step 2, we're going to determine the symbol of the second element. Now remember, the ending, the IDE, means that the name represents an element on the periodic table. So if we look on a periodic table, we're not going to find sulfide as an element. Rather, we will see something like sulfur. So once again, that IDE at the end, that's kind of a suffix that we add in to our chemical names. And that IDE just means that this element, sulfide, okay, the beginning part, sulf or sulfur, that's going to be found on the periodic table. So if we look for sulfur, the symbol for that is going to be S. So we have sodium and we have sulfur. And so in step 3, we're going to place the two symbols side by side in the correct order, and we're going to write their charge, sometimes called the combining capacities, at the top right of each element's symbol. If the metal has a choice of charges, we're going to use the one shown by the Roman numeral in its name. And we're going to ignore the positive and negative signs at this point. So if you look at sodium on a periodic table, you'll notice that the charge for sodium is a positive, okay, or the positive invisible 1. So we're just going to write 1. And the charge for sulfur is a -2. We're going to ignore the minus sign or the negative sign, and we're just going to put the 2. Once we have the charges written down, what we're going to do in step 4 is we're going to cross over the charges, okay? So sometimes different teachers might use different languages. I often like to use cross over or cross down. Some people say crisscross, but the idea is the same, is that these superscripts, when they cross down, they're going to become the subscripts. Okay, so the 1 from Na crosses over to become the subscript for sulfur, and the 2 from the sulfur is going to cross over to become the subscript 2 for sodium. And so by the end of step 4, we have Na2S1. And in step 5, we're going to reduce the subscript if they have a common factor, and we're going to clean up by deleting all the 1s. Okay, so the 1 here gets deleted, and so for sodium sulfide, the chemical formula is Na2S. Here's another example. We have ammonium sulfate. So let's write ammonium sulfate as its chemical formulas. And so if we look on a periodic table, you're going to notice that you're not going to find ammonium or sulfate anywhere on the periodic table. And that's because ammonium and sulfate, these are what we called polyatomic ions. So these are groups of atoms that come together to form either a cation or an anion. And so it looks more complicated. You can look on the list of the polyatomic ions, but the procedures are the same as all the other examples. So let's go through this example. Ammonium sulfate. Step 1. Determine the symbol of the first part. So ammonium, when you look at it at the polyatomic ions list, ammonium is NH4, okay, with a charge of that 1 or the +1 or the invisible 1. If we take a look at the second part, sulfate, okay, so this is different than sulfide. Remember how the IDE tells us that it's found on the periodic table, but sulfate, this is found on the polyatomic ions list. So sulfate is SO4 2-. And so whenever we use the polyatomic ions, a really good thing to do is to put brackets around each of the polyatomic ions. So you'll notice that in step 3, I have NH4 in brackets. Okay, I've deleted the positive and the negative signs, and I replaced them with just the numbers. So for NH4, that's the 1. I'm going to put brackets around SO4, so the sulfate, with the 2 on top. And I'm going to cross the charges. So once again, the 1 from the ammonium becomes the 2, the 1 for the sulfate. The 2 from the sulfate, that crosses over to become the subscript 2. Once again, we're going to do a little bit of cleanup. If we can reduce the subscripts, we will reduce the subscripts. And we're going to delete all the 1s and remove the brackets if there's no subscripts following them. So after we clean up, from step 3, we end up with kind of in brackets NH4, 2, and then SO4. So this here is our final answer for ammonium sulfate. Let's take a look at another example here. Write iron 3 chloride as its chemical formula. This time you'll note that there's a Roman numeral 3 following iron. And that's because a lot of these transition metals could have more than one charge. If you look on a periodic table, iron can either have a 2+ charge or a 3+ charge. And so this Roman numeral 3 is telling us what that charge is going to be. And the procedures are the same. So step 1, we're going to determine the symbol of the first part. So Fe, that's the symbol. And because the Roman numeral 3 follows the iron, therefore we know that the charge is going to be 3+. Step 2, we're going to determine the symbol of the second part. So chloride, which is chlorine, that has a charge of that invisible 1. Okay, we're going to put brackets around the polyatomic ions if necessary, and we're going to use the charges and cross over. So we don't have any polyatomic ions, so we don't need any brackets. Okay, so once again here we have Fe. Okay, when we're crossing over, we're going to ignore the positive and the negative signs. Okay, so the 3 from the Fe becomes the 3 subscript for chlorine, and the 1 from the chlorine becomes the subscript 1 for iron. Once again, in step 4, we're going to do a little bit of cleanup. So anytime we have 1, we're going to delete it. If we have brackets, then we're going to delete, if we have brackets with no subscripts after them, we're going to delete that as well. And so kind of our final answer for iron 3 chloride is going to be FeCl3. Okay, so with that, please give these examples a try. If you want to pause the video right now, you can, and then give that a try. And then when you feel like you've attempted these questions and you're ready to check the answers, then you can continue the video. Okay, so hopefully you've checked the answer and hopefully they are all correct. And so that's the first part, ionic compounds, writing formulas for ionic compounds. So the second section here is writing formulas for covalent compounds. And so to recap once again, covalent compounds, these are types of compounds formed by the sharing of electrons between atoms. Covalent compounds are formed between two nonmetals. And so I think this is probably one of the most key points here. is that covalent compounds, they are two non-metal elements. So on the periodic table, the first element has to be a non-metal, and the second element also has to be a non-metal as well. And so it's pretty black and white in terms of the compounds here. If it's not a covalent compound, then it's usually an ionic compound. And so when I'm looking at different compounds, usually what I try to do first is to try to figure out, is this a covalent compound? If yes, great, then I'm going to follow its set of rules. If not, then it's going to be an ionic compound. And so once again, covalent compounds, these are compounds that contain two nonmetal elements. And so let's take a look at an example. Write sulfur hexafluoride as its chemical formula. And so for covalent compounds, we are not looking at charges and we are not looking at crossing over anything. Okay, so charges crossing over, that's only for ionic compounds. For covalent compounds, we're just going to look at the name and we're going to write the formula based off of the name. So step 1, look at the first part of the name to identify the element and the number of them you need to include. If there is no prefix, that's the same as mono or 1. So here we have sulfur, and you'll notice that there's no prefix in front of sulfur, so that means I have 1 sulfur. We're going to do the same thing for the second part. So we have hexafluoride. Okay, so hexa, this is a prefix for 6. Okay, fluoride is fluorine, so we have 6 Fs or 6 fluorines. Step 3, we're going to ignore the charges. We're not going to cross over, and we're just going to write the numbers as the subscripts. So I had 1 sulfur, so that's just S. I have 6 Fs, 6 fluorines, so that 6 becomes a subscript. And so my final answer here is just SF6. Okay, so once again, there's no crossing over. We're just writing the formula based off of its name. And in case you forgot, here's a list of prefixes. So mono for 1, di 2, tri 3, tetra 4, penta 5, hexa 6, hepta 7, octa 8, nona 9, deca 10. Okay, and so usually most people find kind of writing and naming covalent compounds a little bit easier. And so at this point, once again, if you're comfortable, give these examples a try. Feel free to pause the video, and then when you're ready, you can click resume again. Okay, so hopefully you got these 4 examples correct, and if so, then you're ready to continue on. Okay, so we're going to go back to ionic compounds, but this time we're going to actually write the names of the ionic compound formulas. So let's take a look at an example here. We're going to write Na2O as its chemical name. So first thing we're going to do is Na. We're going to look on the periodic table. So Na is sodium. And then the next thing we're going to do is we're going to look at the next element. So that's the O. We're going to look for it on a periodic table. So that is oxygen. But because this O, this oxygen, is the last part of the name, we're going to make sure that we change the ending to an IDE ending. So instead of oxygen, we're going to keep the first syllable, the ox, and we're going to add that IDE, so it's going to become oxide. So once again, we only change the ending of the second part of the compound, okay, the latter part of the compound. So we're going to put these two together, so we have sodium oxide. Let's take a look at another example here. We have Cu2O. Okay. Now, when you look at Cu, or copper, on the periodic table, you'll notice that copper actually has 2 possible charges. It can either have a +1 charge or it can have a +2 charge. And so to figure out which one it is, we're just going to kind of uncross it. We're going to go backwards a little bit. So if I have Cu2O, if I kind of uncross it, if I go backwards, Cu actually has a 1+ charge. Okay, so this 1+ charge is the one that it gets crossed over and becomes kind of the invisible one behind the oxygen. Okay, so when we uncross the chemical name, we figure out the charge of that first element for copper. And so because it is a 1 charge, then when we write the first element, we're going to use Roman numerals to show that, okay, there were choices to be made and the correct choice is the 1. Okay, so once again, the Roman numerals, we only use them if the element has more than 1 charge. So if I go back to the previous example here for sodium, we're not using any Roman numerals because for sodium, there's only 1 possible charge, the +1. Okay, copper and other elements like gold, cobalt, iron, they have multiple charges on the periodic table, and so that's why we need to use the Roman numerals to show which kind of charge it's going to be. Okay, so we have copper 1, and the rest is the same. We have an O at the end. That O is oxygen. We change it to oxide, and so for Cu2O, the correct name for that is copper 1 oxide. Now, another kind of way to know if an element has kind of multiple charges is that most of the time it's the transition metals that have multiple charges. So your group 1, your group 2 metals, they will always have kind of either a +1 charge for group 1 or a +2 charge for group 2. But it's the transition metals the transition metals in between that could have multiple charges. Okay, let's take a look at another example here. We have kind of NH4 in brackets, okay, 2CO3. Okay, so same thing, when you look at it, it looks really complicated because there's so many elements in there. Okay, and so when things look a little bit complicated, just keep in mind that these could be polyatomic ions. So if you look on the polyatomic ion list, you'll notice that we have NH4, and NH4 is ammonium. The second part here, we have CO3. Okay, so if you look on, once again, the polyatomic list, you'll notice that we have CO3 2-, and that ion, that polyatomic ion is carbonate. And so when we're looking at polyatomic atoms, we don't have to change any endings. We put them together, and so this formula here, this is ammonium carbonate. Okay, so give these examples a go and see if you can write the names for these ionic compounds. Okay, and so that's naming for ionic compounds. We're going to move on to naming for covalent compounds. And so once again, with the covalent compounds, the rules are a little bit more simpler. There's no charges, you're not crossing, you're not uncrossing, there's no Roman numerals, and all it really is you name it based on what you see. Okay, so let's take a look. We have C, Cl4. Now, just be a little bit careful because sometimes in the text, the I's and the L's look similar. Okay, so in this case, this is actually an L, so this is CCl4. So we're not going to use any charges. In step 2, we're going to use the prefixes from the table before to give the number of each element. So when we look at carbon here, we only have one carbon. Okay, so we only have one carbon. We do have 4 chlorines, so we have 4 chlorines. And so from the prefix table, that is monocarbon, right? 1 carbon, tetrachlorine. And in step 3, we're going to do a little bit of cleanup. If the first element is mono, or if the first element has mono as its prefix, we can ignore it, so we can cancel that one out. And don't forget to change the ending of the second element. So this chlorine here, we need to change the ending a little bit. And so CCl4 is carbon tetrachloride. Okay, so keep in mind that the only time that we can kind of ignore mono is if it's in the first element. If it's in the second element, then we have to keep the mono. Okay, let's give these examples a go. Okay, and that's naming covalent compounds. So the next type of naming that we're going to do is naming acids. And so acids, these are a type of ionic compounds that starts with the hydride ion H+. Okay, so a lot of ionic compounds, if it starts with H, like HI, HCl, okay, sulfuric acid, H2SO4, these are what we called acids. Okay, so once again, acids are ionic compounds that start with the hydride H+. And so there's kind of 3 types or 3 different ways to name acids, and it depends on what type of anion it's being combined with. So if I have the hydride ion H and it's being combined with a halogen, the way we name these acid is going to be hydro and then kind of the halogen here and then an ic acid. Okay, so HI, we're going to have the hydro, okay, and the iotic, and then acid. Okay, so HF, okay, so F here, this is the halogen. So by following the same pattern, this is going to be hydro, okay, the prefix part of the halogen, so hydrofluoric acid. Okay, HCl, okay, the Cl here, that's the halogen, so the name for that is going to be hydrochloric acid. Following the same pattern here, if we have Br as the anion, Br is a halogen, so this is going to be hydrobromic acid. So that's the first type of naming acids, if the H is being combined with a halogen. Sometimes the H is being combined with a polyatomic ion that ends with an ATE. Okay, so anytime H plus is being combined with a polyatomic ion that ends with 8, like for example, carbonate, sulfate, nitrate, phosphate, what we're going to do is we're going to keep the prefix of that 8 ion and just change the ending to an IC or ic acid. Okay, so for example, this polyatomic ion here, this CO3, this is carbonate. And so what we're going to do is we're going to keep the first part, which is the car, okay, the carb, or the carbo, and this is going to be the carbonic acid. Okay, so the carbonate, the carbo, and then we keep the IC, okay, we pronounce it as carbonic acid. Okay. Same thing here when we look at the anion here, SO4. If we look on the polyatomic ion list, SO4 is sulfate. And so when we combine it with an H, it becomes an acid. And this acid, following the same pattern here, we're going to keep the first part of sulfate. Okay, so kind of the sol, and then we're going to add an IC acid. Okay, now sulfic acid doesn't sound as smooth, and so what scientists have done is they decided to keep kind of the sulfur part of the sulfate, okay, and then add the IC acid. So instead of sulfic acid, to make it sound a little bit more smooth, okay, this is sulfuric acid. Okay, so sulfuric acid. Next example here, we have the NO3, the nitrate, as the anion. Okay, so we're going to keep kind of the first part of the name, nitric acid. Okay. And then so the third way to kind of name acids here is if we look on the polyatomic ion list again, some of those polyatomic ions end with an ITE, like nitrite, sulfite, phosphite. And so if the polyatomic ion ends with an ITE, when it combines with an H plus to form an acid, we're going to keep the first part of its name, but we're going to change kind of the ending of it to an OUS acid or US acid. Okay, so let's take a look at a few examples here. So we have SO3, this is sulfite. Okay, so this is an ITE ion, sulfite. Okay, and so when we combine it with an H, we're going to have sulfurous acid. Okay, ClO2 minus, if you look on the polyatomic ion list, this is chloride. And so when we combine it with an H to form an acid, this is going to be chlorous acid. And so this is naming acids. And the last thing that we're going to learn, and this should be new, is kind of naming kind of hydrates. And so hydrates, these are ionic compounds that have water molecules kind of trapped in its crystal structures. Okay, so you may have learned that ionic compounds, they're like a crystal lattice. It's very organized, of alternating or in different patterns, with the elements in different patterns. And sometimes in its crystal structure, crystal lattice, there are water molecules trapped inside. Okay, and so that's what we call hydrates. And so to name hydrates, all we're going to do is use the prefix system again to indicate the number of water molecules, and we're going to add in the word hydrate. Okay, so for example here, if we take a look at this equation, this looks super complicated. We have CuSO4, and then something that's new is, okay, you see this little dot there, and then we have 5H2O kind of behind it. Okay, so CuSO4, we're going to name it normally, so that's copper sulfate. Okay, this dot here means, okay, well, in this ionic compound, CuSO4, copper 2 sulfate, okay, so in one copper sulfate, I have kind of 5 water molecules kind of trapped in its crystal structure. Okay, so the 5 here, this is the penta, and then the H2O, that's going to be the hydrate. Okay, so it's quite simple. We just add in the prefix for however many hydrate or water molecules we have. To write the chemical formulas of an ionic compound with water molecules, okay, we're going to start by determining kind of how many of these water molecules do we have. Then we're going to put H2O as the water molecule, and we're just going to separate the ionic compounds and the water molecules with the dot. Okay, so let's take a look at an example here. We have iron 3 phosphate octahydrate. Okay, so if I try to decipher this, iron 3 phosphate, that's my ionic compound, and then I have octa, so 8, hydrate 8 kind of water molecules. Okay, so iron 3 phosphate, this is the beginning part. Okay, I have a dot to separate my ionic compound from my water molecules. 8 hydrates, so 8 H2Os. Okay, one final set of examples to try. Okay, and so this is the end of lesson 0.2. I will see you all next time. And then email me if there are any errors or if you have any questions. See you all next time.